All right, today we begin our unit on naming chemical compounds. We start off with simple binary ionic compounds. Binary means that there are two elements. Bi means two. Ionic means they are formed from a cation and an anion. Today that will be a metal and a nonmetal. Most times when we get into polyatomics, here soon we'll see how that changes, but for today it will simply be a metal and a nonmetal combining to form a compound. Naming involves going two different directions. It involves seeing the name of a compound written out and being able to write the formula, which is a big part of chemistry for the rest of this semester and next. And it also means being able to see the formula and write the name of the compound. So we'll look at it both directions. With a simple binary ionic compound, it's not very hard to go from the formula to the name, so we will start with that. So keep in mind, all of these compounds will have a metal, and our metals are found over here. And for today it's really simple. Our metals are going to come from group 1 and group 2, or aluminum. Those are the only metals we'll be concerned with for today and tomorrow. And our nonmetals, of course, are over here, up on the stair step. These form our anions, or negative ions. So, if we've got the formula and we want to be able to write the name, we only have to remember two things, really. The metal keeps the name of the metal name. Sodium is sodium. Barium is barium. Strontium is strontium. Aluminum is aluminum. It doesn't change. And the nonmetal, we drop the ending and it ends in ide. I-D-E. So for example, this compound right here, our metal is sodium, our nonmetal is chlorine. So it's not called sodium chlorine, but sodium chloride. If you had CaF2, we have calcium and fluorine combining here. Calcium fluoride. They all end in that IDE when we do this. You'll see IDE on each one of them. We have one more example there of going from the formula to the name. We have BaO here, which would just be barium. That's Ba. O is oxygen, and it ends in oxide. So, if you see the formula and you want the name, the first thing you've got to make sure is that this is a metal to start it off with, like sodium, calcium, barium, aluminum, strontium, etc., and so on. If it starts with a metal, we are using this naming system, so it'll just be the metal name, and the anion will end in ide. That's the easy part. It's a little harder when you want to go the other direction. When you want to go from the name to the formula. When you have the name written out and want to figure out what the formula is. How do I know that this is one sodium and this is one chlorine, but this compound is one calcium and two fluorines? How do I figure that out? Well, these are ionic compounds. And if you remember, ions are simply atoms that have a charge. And with an ionic compound, the charges tell us how they combine. Because elements are neutral. Remember, they have the same number of electrons and protons, so they don't have a net charge. They are neutral. And ionic compounds are the same way. There will be no net charge when you're done. So what that tells us is that the positives and the negatives have to balance out. We'll just look at these three right here. So what you've got to do is figure out the charges of each one. How do I do that? Look at your periodic table and remember when we studied the ions and looked back on them. Remember, every element here in group 1 wanted to lose one electron. Because if sodium loses an electron, it's got the same configuration as neon, and it's happy then, because they all want to be like those noble gases. So these guys all want to lose an electron. They all form a +1 charge. So every group 1 or alkali metal forms a +1 charge. In group 2, all of these guys want to lose 2 electrons, and they form a +3 charge. The only other one we're going to worry about today is aluminum. Here soon we'll throw the rest of these into the mix, but for today, just aluminum. And aluminum has a +3 charge when it is an ion. On the nonmetal side, it's a lot easier. All of these guys want to gain 1 electron. These all form a -1 charge. These guys right here want to gain 2 electrons. They form a -2 charge. And finally, group 15, nitrogen, phosphorus, and arsenic want to gain 3 electrons, so they form a -3 charge. So, once you're able to figure out what charge each component has, you just figure out how they have to combine so that the charges cancel out. In other words, the total amount of positive and the total amount of negative will be the same, so you have a net of 0. Let me show you what I mean. We'll start right here with sodium chloride. So I see sodium, it is in group 1, so it has a +1 charge. And I look at chlorine, which is over there, it's a halogen in group 17. It gains 1 electron, it has a -1 charge. So if one sodium ion is +1 and one chlorine ion is -1, if they combine 1 to 1, they balance out. It's NaCl. +1 -1 is a net 0. And that's what you're after. You don't want any charge. So you just play with them and basically add ions until you're at a net charge of 0. Let's look at this one here, calcium fluoride. When you find calcium on the periodic table, it's right here in group 2. So it forms a +2 charge. Fluorine is another halogen, so it's a -1. So I've got calcium, which forms a 2+, and fluorine at -1. Now, I've got 2 positives and only 1 negative. So I need more negative, right? Because I want to have the same amount of positive and negative when these combine to make a compound, and that lets it be neutral. So 1 calcium and 1 fluorine gives me a net of a +1. That doesn't work. But if I had another fluorine ion, now I've got a total of 2+ and a total of 2-. And that's exactly what we're looking for. So that tells me that 1 calcium will combine with 2 fluorines for a formula of CaF2. 1 calcium combines with 2 fluorines. So let's look at another one then. Let's say we had this written out. Aluminum, we'll do bromide. To be able to write the formula, you have to start with figuring out what charge each ion has. Because we know this is a metal and a nonmetal. So if it's a metal and a nonmetal, it's going to be ionic. And if it's ionic, the charges are our guide. So as aluminum is the one you had to learn, it's a 3+. And then bromine, Br, is a -1. So I have 3 positives, but only 1 minus. And the easiest way at the start to get used to doing this is just whichever one you have these stuff, add another one. So I need another bromine. Okay. Now I've got 3 pluses and 2 minuses. I'm not there yet. I need another bromine. Now I have 3 pluses and 3 minuses. +3 -3. That's what I'm after. So I know that this compound is AlBr3. And it is always written this way. You don't write a 3 in front of it or anything like that. It is a subscript 3. And that tells us that one formula unit of aluminum bromide has one aluminum atom and 3 bromine atoms. That's the way they combine. It takes 3 bromine atoms will bond to 1 aluminum atom, and that gives us aluminum bromide, and its formula is AlBr3. Let's look at a couple more examples. We'll keep aluminum. Heck, we'll kick it up a notch. We'll make it a little harder. We're going to do aluminum oxide. All right? We're going to figure out how these combine and write the formula for aluminum oxide. Once we get all the rules, you're going to have to remember the first thing to do is check and make sure, yes, this is a metal and a nonmetal. This is going to be ionic. So I use my ions. So I've got aluminum at 3+. It's one we had to learn. Oxide, when I look over there and see it on the chart over here, I see it right over here. So it is a 2- from that group. It needs to gain 2 electrons. So I've got 3+ and 2-. So I've got more pluses, right? So what I said was the one that's least, you write another one of them. So I'll add an oxygen. Now I've got 3+ and 4-. Now I have more minus. Well, okay, I'll just follow the rule. I'll write another aluminum. So now I have 6 pluses, I still only have 4 minuses. I've got more of these, so I'm going to write another oxygen over there. Now if I look, I've got 6 plus and 6 minus. And that's what we're after with ionic. We want those numbers to be the same. So that means when this forms a compound, there are 2 aluminums and 3 oxygen atoms. So we write our formula, Al2O3. That is aluminum oxide. And that is how you write the formula when you have the name of binary ionic compounds.